Hello, welcome to Star West and welcome to Hey, You Got Security in My Development. My name is Gene Gadamer and I'm going to be presenting a list or a couple ideas on how to improve security throughout your development lifecycle. And these are all practical ideas. This is not something you're going to need to go out and get a bunch of security engineers fully tasked to be able to do this. This is something that most developers and testers should be able to work into their pipeline and work into their development lifecycle practically without a whole lot of effort, using mostly free tools. I'll give you some suggestions as we go through, but we're really looking for not the tools specifically, but what opportunities can we create for ourselves to make sure we're developing more secure software. Uh, for those of you that are not as old as I am and may not recognize the picture in the background there, that's an old Reese's ad from the late 70s and early 80s, where they used to run a campaign about, hey, you got peanut butter in my chocolate, hey, you got chocolate on my peanut butter, when two people would run into each other. And that's the idea, was that the resulting combination was better than either of them individually. And that's really what we're looking for in DevSecOps, is that by combining security and development, not running them as separate phases or doing them in silos, what we get is something that's much stronger than would have been with the pieces on their own. So let's look at a traditional pipeline with late security, which is what we normally see. We could look at our development lifecycle as kind of 4 stages, right? We start doing our planning, and once the planning's all done, we have our requirements. We start our coding, we do the coding, and then there's a fairly long test phase where we do all sorts of testing. Sometimes it's this whole test group that's doing it. Sometimes it's actually a combination of developers, testers, other groups like security and performance all doing their testing. And finally, we get out to release. What happens is in a traditional setup is that our security scanning tends to take place late in the test cycle. It's another group often, specialized knowledge, specialized tools. So you don't get involved with security until towards the end. The problem with that is our feedback loop tends to be when we go to release, we either release or we don't. And that's really the only time we make a decision in our security-wise in our life cycle. We basically bundle up all the testing that's been done, and we make a go, no-go call right when we're going to release. And the problem with that is we don't have time to react. We're not being proactive. The other problem really that we see is our confidence throughout it is pretty low. By the time we get to release, maybe it's getting a little bit better, but it's really not good, right? We don't really get confident in our release until after it's gone out and we finish crossing our fingers and it's stayed up for a couple days and we haven't seen any major problems, and then we can kind of breathe our sigh of relief. And that's not what we're looking for, right? The promise of DevSecOps is that we could do all sorts of security testing throughout, right? We could do all sorts of things. I'm going to go through each of these, but the big thing is there's something that's going on at every part of our software development lifecycle, including after release, during planning, during coding, during testing, and even after we release the software, right? And that's something that's really important to understand about DevSecOps, right? We're trying to spread this out throughout, not just one shot at security towards the end. The other thing is that each of those points provides feedback. That's not just one round of feedback, go, no go, based on security. That is, we're going to do some security requirements during the planning phase, and we're going to work that back in to improve them on the next round, right? On the next release, on the next build even, right? And as we go through, each time we do some tests, do some checks, we get more information, learn more about the security posture of our systems. We're going to feed that back into our next planning phase. And these things are going to happen concurrently, right? This is something we're always releasing. We're always working on the next build. And so we're going to get feedback constantly, right? And that's a huge part of DevSecOps. If you've read the Phoenix Project, and if you haven't, I highly suggest you do, by Gene Kim and a couple others. But the Phoenix Project calls this the second way, right? It's the constant feedback. It's amplifying feedback loops and learning from that, which is the third way. The result of this, when we're getting all that feedback and we're able to make decisions and we can don't have to wait till go, no go right before release. We can, you know, during the coding phase, we can find some problems and say, hey, this build is not going to make it. This is not a viable candidate for production. It doesn't matter what happens after this. We know this is never going to go live. So let's cut our losses here. Let's go back to the drawing board and let's fix that problem and then move through and not waste time testing and updating and all that on something that we know won't go live. The end result of that is by the time we get to release, we're confident. In fact, that's what DevOps and DevSecOps is about, is building a pipeline such that when it comes time to release, we are confident that we are releasing something that's a viable candidate for production, right? That's the whole goal. And by having all this extra feedback and doing all these extra rounds of tests and checks and security operations on the security side, at least, is going to give us that confidence by the time we release and beyond. All right, so let's talk about some of the things we can do during planning. First off, we always do requirements, right? That's really what the planning phase is mostly about, but we hardly ever do security requirements. Security requirements, not just what should you be able to do, but what should you not be able to do? What happens when someone tries to do something and it's turned down, right? They're not allowed to do that. What types of things can we do that are saying, hey, this shouldn't be able to happen? We want to make sure this doesn't happen, right? And we usually have some roles, right? Who should be able to do this? Who shouldn't be able to do this? In this situation, they can. In this situation, they can't. Sometimes it's not just a binary yes or no. Sometimes it's also, are there special cases, right? You know, they can say, for instance, in this chart I show here, I'll talk about it in a second, but, you know, a logged in user might be able to edit their own profile, right? No one else can edit somebody else's profile unless you're an admin, but an admin might only be able to edit certain fields or should only be able to edit certain fields with some sort of audit logging or some sort of notification to the user so they can't just do things on people's behalf and pretend it was the user themselves. One of the places we used this really successfully was on a DoD project I worked on a number of years ago. And one of the things the team had come up with was starting to do this. We were doing it as user role testing later in the phase, but it ended up being security requirements. Every time we started a story, every time we started working on a new feature, it wasn't just how should this work, but how should other people be able to interact with this? How should these roles not be able to do it? What's that behavior look like? What happens? Do they get an error message? Do they get something really clear? Do they just turn them down? Is the button just not there? Right? What's the behavior in the haves and the have-not cases? And what we found was the biggest benefit we thought was going to be towards writing functional tests for the have-nots, for the negative cases, the security cases. But it ended up that a big benefit that we found was up front doing the security requirements. Every time we started off a story, we started having this conversation, and our understanding of what the behavior should and shouldn't be became really, really strong long before we started building. And that really helped us in providing a really strong set of user roles and having them behave the way they should be. All right, after your security requirements, you want to probably do some threat modeling. Kind of once you know how it's supposed to behave and what it's supposed to do, you need to understand what's your security situation, right? What are the threats? What are the risks due to those threats? And if one of those risks come to pass, if someone gets a hold of this information or breaks the integrity of the system, what's the impact? And how are we going to mitigate it? What are we going to do when it happens? Or what are we going to do to make sure that it doesn't happen? How are we going to make sure that that's not a case that's likely, right? We're never going to eliminate all the risks. We're never going to remove all the impacts. But what can we do to make sure that they're as minimized as possible, right? That we can recover from them so we can detect them, that type of thing. A great model, there's a lot of models out there, but a great model to use is something called Stride. Microsoft has it as part of their secure software development lifecycle. The URL's there. But what they do is they actually have a tool that goes with it. It used to be based on Visio that you could actually draw out a system diagram and mark different pieces, different elements in different ways. And once you got it kind of all drawn out and where the threat boundaries were and set a couple things up, it would walk you through a checklist and just say, hey, have you addressed this? Have you addressed that? Right? And all it did was an automated check. All it does is it provides you an automated checklist to say, consider this, right? Consider how each of these things affect the security posture of the system, just so that you make sure that you know what risks you're taking, what threats you're addressing, what mitigations you're providing, so you really understand what the situation is. Like I said, you're never going to fix them all, but this is a good, very orderly, organized way to go through and understand your threats. Now, if you don't want to go into stride, it's worthwhile still doing some threat modeling, and to me, I call that back of the napkin. Just talk it out. What are the real risks we're having? What are the real things we're worried about? What's our nightmare scenario? And if that doesn't come to pass, what's the next nightmare scenario? Or once we prevent that, what's our next nightmare scenario, right? And just start talking it out like that. And if you do this on a regular basis throughout, every time you're adding new features, like how is this going to change our risks? How is this going to change our threats? You get to learn a lot about your situation security-wise, and keep that in mind as you're building the software, right? Rather than trying to tack it on after you've built the system and then try to figure out, okay, what are we really worried about? How are we going to lock this down? So threat modeling, whether it's formal or informal, is very much worthwhile during the planning phase. All right, so after we've planned, then we want to get into maybe some of the stuff we can do during coding, right? We build our code, and one of the things a lot of people put into their pipelines is static code analysis. If you don't use any tools right now for it, I highly recommend the open source Sonar Cube. They have some commercial versions out there as well, but it just runs tests against your code to check the code quality. Not that the code works the way it's supposed to, but that the code is written the way it's supposed to be, right? It checks things like code style and looks for copy and pasted code that's largely the same or exactly the same throughout your different parts of your software. Look for recommended code practices. You should apply this, you shouldn't apply that, right? It looks for confusing code, places where it might just be hard to follow along later, 3 months down the road, 6 months down the road, when you or someone else is trying to make other changes to it and could potentially introduce problems because they don't understand what it's doing. Something like an if not this, then else, right? A negative if then else that might be easier to read the other way around, or too many nested loops, things like that. Long methods. The other thing, it actually will check for some simple security flaws. Some most simple types of SQL injection can be found very straightforwardly by a tool like Sonar Cube or the analyzers it runs underneath the covers, just looking for a string concatenation, right? And it can pick up those. One other thing that's really good at doing that Dynamic is not good at looking at is race conditions, right? Two things happening at the same time in almost exactly lockstep, but just gets out of order a little bit, and all of a sudden creates a problem that can be almost impossible to recreate dynamically. But through path analysis, source code analyzers can actually find them, and that could cause you to find some potential security and availability flaws early on in your development. But the biggest thing I see for security-wise with looking at the code quality and making sure the code quality is high is that you're looking through, it's doing an automated code review, looking for the things that your team has just decided these are the way we will do things, right? And what that sets you up for is really good peer reviews. Now we can do code reviews looking for stuff that the code analyzers can't, right? We don't have to call a big meeting, get everyone together to tear apart someone's code because we don't like the way they capitalize their variable names, or we don't like tabs versus spaces, or we wish they had renamed things, right? All that is stuff we can put into our static code analysis so that we can look at the stuff that's truly subjective. And what we really would like to do is do this continuously, not just once a month we pick on some poor developer's code and tear it to shreds, but rather every time we do a pull request or a merge request, somebody looks through and says, hey, I know the static code analysis is already run, so I don't need to look for the simple stuff, right? I know it compiles, I know the unit tests run, so now I'm getting into the subjective stuff. So I can spend my time looking at the architecture, using or misusing frameworks, right? Usually a lot of that will come up with input and output handling. Are we looking at the input and making sure we're not trusting it directly, we're encoding output correctly when we're sending it back out, so we can't have cross-site scripting, cross-site request forgeries, that type of thing. The other thing we can look for is things where people might be rolling their own instead of using a framework, right? Rolling your own encryption, cardinal sin of development, of security rather, right? Or rolling your own authorization authentication schemes, right? It's too easy to miss some major pieces of those, and there are plenty of frameworks out there that already implement those, and you probably have one or a collection of them that you use in your software in your organization. And if you just go ahead and use the one that's kind of blessed by the architecture group, or that all the development teams have gotten together and picked, or even just that the team before you has used, you gain more knowledge with using it correctly and not leaving holes. And you're also just not rolling your own, right? The other thing to look at that stat code analysis can't look at is error handling. A lot of times in the code, we'll just throw up an exception. Hey, this didn't work. But we want to catch that and handle that right. So the right message goes back to the user. So the right messages go in the log so we know what to do with it. So it's not just that, hey, things died, things didn't work. It's actually something that we can react to and handle correctly. So by doing the automated static code analysis, we can do these peer reviews that are actually much more meaningful, like I said, rather than getting into arguments about tabs versus spaces. Now, this is probably the first thing that we get into that you can really do that's completely security related, really easy to implement. This is a really low-hanging fruit thing that you can add into your development lifecycle. And it addresses something called that OWASP, the Open Web Application Security Project, list in their 2017 list as A9. It is one of the OWASP top 10, and it's called Using Components with Known Vulnerabilities, right? And these are libraries that you might be using in most of our frameworks. Most of our code that we release today is really not code that we wrote, but frameworks that are providing us, that we're stringing together, providing us the capabilities we need. A lot of times those libraries have known vulnerabilities, what they call CVEs, common vulnerability enumerations, right? These are lists of known bugs. They have security holes in them. And it may be new version has come out, or maybe a new version hasn't. We just need to know what the mitigation is, or what we can and can't use, or switch libraries. But it's not just the libraries we're using. Those libraries are usually built on top of libraries, and those libraries are usually built on top of libraries. So we have dependencies of dependencies. So it's really hard to keep track of them, especially in today's day and age. So there's a tool out there called OWASP Dependency Check. There's a lot of security tools, commercial security tools that will also do software composition analysis, often abbreviated as SCA. And what this will do is just look at your software bill of materials and just look through your build scripts, right? If you're doing this in Java using Maven, it just looks through the Maven files through the POM, and it just finds what libraries you're including and what libraries those are including. And it just matches that up against a database that it constantly updates and says, here are some vulnerabilities that you have because you're including these libraries, and you have to figure out a way to mitigate them, right? And some of the commercial tools have better ways of handling that. So definitely worth adding in. Very easy, very low-hanging fruit. It's also very easy to remediate. It's simple for developers to learn, oh, I just need to upgrade that package, and we've cleaned up a potential vulnerability that we're releasing that we could be releasing. This, the scenario that's almost always brought up when we talk about software composition analysis, this was the Equifax breach. They were using an older version of struts. They didn't realize where they were using that struts, and they had a hole open for many months, all because they did not know that what applications were using this vulnerable version of struts that they could have just updated to a new version or gotten rid of completely if they weren't using it. And that would have closed their hole. All right, so those are some of the things you can do during coding. We already talked about stuff you might do during planning. Let's get to the longest part of our development lifecycle, and that's the testing part, right? During testing, one of the first things that normally kicks off the testing phase is that we go ahead and we deploy, right? And this is someplace where you can really open yourself up for a lot of opportunities. Now, this is obviously a major part of DevOps, which is repeatable, reliable deployments, right? Using automated deployment tools, things like Docker or Chef or Ansible or Puppet that will allow you to write infrastructure as code and deploys as code that can be tested. And once you get into to a point is that you're doing these deploys constantly throughout your life cycle, and you get to the point where testing in your development environment looks just like testing in production because those boxes look the same. Well, if we don't have to wait till we get to production or near production to do our security scanning, well, now we can do security scanning much earlier, right? We can do all sorts of checks a lot earlier. Well, one thing we'll find out, you come up with reasons rather than saying, why should I go through the trouble of deploying, but rather, hey, there's no reason not to. So you start deploying much more often because you can deploy so much more easily because it's all automated, right? And the other thing that having these repeatable, reliable deployments will allow you to do is to create dynamic environments. And dynamic environments are much better than static environments for a whole lot of reasons. A dynamic environment is one that you stand up, you use it, and when you're done with it, you tear it back down. It's not pinned up. It's not the dev environment that everybody has the link to, and that box just keeps getting written over and over and over. Every time there's a new version, it builds up all the cruft and everything. Dynamic environments you can have just on demand. Hey, I need to do a demo. Hey, we'll spin you up a new environment. Hey, I need to be able to do this security scan. It's going to take 3 days. Great, I'll spin you up a new environment and set it off to the side for you. And you just stand them up, you use them till you're done, you tear it back down. Even for just regular testing, right? You can start doing destructive testing and knowing that if you manage to corrupt, let's say, the database or the data in the database because you found a vulnerability, you found a bug in the system, you haven't killed anybody else's testing from here on, because now you have a dynamic environment that you tear back down when that test is done, and you stand up a brand new environment to run your next set of tests or to run the next build through, and it doesn't have the problems that you just inserted, right? On demand also means fewer resources being used because you're only paying for what you're using, so it ends up being less expensive. Plus, it gives you some really great disaster recovery capabilities because, hey, if the system gets taken down, if the data center gets hit by a major storm and you have to bring it up somewhere else, hey, that's no problem. We'll just spin it up in another data center somewhere else in the cloud. It lets you do scaling a lot easier. Often you can just say, hey, we're about to come up to our busy season. I'm going to spin up 3 or 4 more of these instances, and we'll just put them behind a load balancer. And when we're done with those, hey, we'll just tear them back down. We don't need to pay for our major seasonal capacity or our peak capacity all year long. So you want to strive towards repeatable, reliable deployments. And one of the things that's going to allow you to do is to start doing some application scanning. Well, now that we have the code deployed, right, we can start doing our normal testing, and we want to start by scanning applications, right? This is looking at the application itself to look for cross-site scripting, that type of thing if we're doing web apps. There's some tools out there that can do passive scanning, some that do active scanning, and there's something called fuzzing. One of the tools we really like to use is OWASP-Zap. It's free. It works very much like Fiddler if you've ever used that. You stick it in between your browser and the server that it's hitting, and it just watches the traffic back and forth. In that mode, it can be completely passive. In other words, you could be testing production if you wanted to, and it wouldn't be changing anything going back and forth. The neat thing about that is you can start piggybacking on your functional tests. You can even piggyback on your manual tests. If you just do your normal functional testing, let's say you're using Selenium or a tool like that, you pipe that through OWASP-Zap, and it just watches the traffic back and forth looking for any cross-site scripting vulnerabilities or any evidence of data leakage, any passwords going in the clear, that type of thing. It can get into other things too, like active scanning, like trying to attack a system, especially once it's done some passive scanning. You can do some more active scanning, trying to see if there's any holes that didn't find. And then the last thing that we use is something called fuzzing that OWASP-Zap will do as well. And there's plenty of other tools that will do this, but fuzzing is trying to attack input fields with lots and lots of different types of data, like all sorts of long strings, short strings, random strings. Send a list through a dictionary and just keep trying all sorts of different combinations of funny characters to see if any of them break things. And that can lead to you finding problems that you wouldn't be able to do if you were manually testing sunny day scenarios or things like that. Also, since we have the system set up, we can start doing system updating, right? We're actually deployed to a system, and because we're doing repeatable, reliable deploys, we can start having our test systems and our dev systems look very much like production. And so now we want to keep our systems up to date and patch them all. And there's a lot of good things about this. One thing is, rather than just having dev be the latest and greatest, but test and prod maintained by some other group that's only doing updating once a month or something like that, we can actually keep them all in lockstep. That has some really, really nice features. One is when we do our testing throughout the lifecycle, when we do our scanning throughout the lifecycle, we're always doing it against the as-patched version. So our confidence that it's going to work when we get to production is very high, because we're not going to say, hey, we're using this version of this software, not our software, but the software we're relying on, the EOS, it patched at this state. We're not having it at different points or different levels throughout the life cycle. So we're always doing as it's patched. The other thing is we can do these proactively, and we can do it continuously, right? Every time an update comes out, we can just go ahead and push out the new version so that the next set of tests that run against the updated version. So by the time we get to our production version, we know it's been running with the latest and greatest. We don't have to worry about, hey, will updating this break our app, because we've already tested that way. One suggestion I have with this, aside from just doing whatever your normal updating is and do it on a regular basis, don't wait until you're forced to do it. So be proactive. But one is just follow the announcements. The DHS CISA group actually has a mailing list that goes out once. They mail out to once a week with just a list of the weekly vulnerabilities, and you can just scan through that once a week and figure out, hey, do I have any of this software? Is this stuff that I need to upgrade? Even better if you just have it automatically always take the latest and greatest. But if you want some control over it and you're not quite ready to that, read through the weekly vulnerability summary from CISA and see what needs to be updated this week so you can stay up to date and be proactive about your patching. Now that everything's patched, we can do some hardening, right? Locking it down, making it more secure, right? And we want to do that with our dev systems just like production for a couple reasons. One is that way when we scan and test, we're doing it in the system that looks like production. But the other thing is a lot of our work now happens in the cloud. And once you have a system out there in the cloud, there's no such thing as just a dev system or just a test system that a hacker won't want. Most hackers aren't trying to hack your system, they're trying to hack a system. They're trying to get a foot in the door. And so you can't just leave your dev system completely unlocked because it doesn't have production data or it's just a dev system. So we want to harden all our systems. And to make sure we're actually hardening the systems, we make sure we're actually locking them down, we can use a tool like Inspec, which is supported by Chef, that just allows us to write tests, and they have downloadable profiles that will let you scan through your system and just make sure that your system is audited, and you're basically auditing yourself to make sure you're going to pass your official audit that might happen at the end, right? They call that compliance as code. We can actually run this test against your system to make sure it's configured and locked down the way it's supposed to be. And anytime you have to make a change, you can even change the compliance checks. You see that everything fails, you push out a new patch that fixes it, and sure enough, it all gets cleaned up, right? Compliance is code. One other thing that's really good, and I'm sure this is jaded experience for me, but check what should be off is off and what should be on is on. A lot of times we'll check to make sure things are turned off, but you can also use Inspec or auditing tools to make sure that, hey, on a database server, we have this port open, right? And you want to make sure that that port doesn't close, so that if all of a sudden some security group comes through and locks everything down, or networking group makes some changes to the network, and all of a sudden you're not connected the way you thought you were, and you're going through a different firewall, you'll notice that, hey, we no longer have a port open to the database, and therefore our web application is going to fail. It pinpoints it really, really quickly. It's a great way to get some assurance of what's breaking, what level is breaking, rather than just hearing a report from users, hey, I can't get to my data anymore, and trying to have to figure out what that means. System scanning, right? We've done some system hardening. Now we can go ahead and scan it, right? With all the hardening in place, with all the patches, because we're doing our system updating, with our code deployed, because we're doing repeatable, reliable deploys. And even all the monitoring that's in place. We want to make sure we're not exposing anything we don't want to. And this is a lot of times done at the system level, right? There are tools out there, commercial tools like Nessus, and most big organizations have a corporate tool. But the other thing you can do is be more proactive about it in your development lifecycle and use an open source tool if you don't have access to whatever commercial tool that your organization's relying on. Something like OpenVAS. Now they've actually changed the name. It's still openvas.org will take you to the right place, but there's a company called Greenbone that monitors it, and they call it the Greenbone Vulnerability Monitor now, or Management now. But anyway, OpenVAS, it's an open source fork of Nessus from back when it went closed source many years ago. And it just looks through for open ports, old software, services that shouldn't be running, things like that. One of the great successes we had using this was because we were using infrastructure as code, we were using Puppet on a DoD project. We were able to make our dev system and our test system look very, very much like our production system, with all the same patches, all the same hardening in it. Everything was done automatically. Then when we could run scans every weekend against our dev and test systems, and on Monday mornings I'd be able to come in and take a look through the reports and just say, hey, here are some things we want to clean up before it gets out to prod, so that when the production security group, the operations groups, go ahead and look at our production systems, we're just confident that they're not going to find anything. Remember, the whole point of this whole pipeline is to build confidence in what we're releasing. So this allows us to do it earlier, plus it keeps our dev and our test systems safer. All right, so now we've got to the point where we can actually release. And remember that DevOps is not just about getting to the release point, right? There's something that happens after that, and that's the life of the system, right? I think it was Chris Bitart says, the system's, the project's not done until our last end user is dead, right? A little bit morbid, but the idea is that after release, we still have to maintain this. There's still feedback to be gotten, and there's still information to be learned, and we still have to be watching this. So what are some things we can do after release to help us understand our security and make sure we're still secure? Well, first of all, log monitoring, right? That's the easy one. If you have a commercial license for Splunk in your organization, you're probably using that. It's a great system. It gets very expensive very quickly. It's a whole major project unto itself. But one of the open source options becoming more popular is called the ELK stack, Elasticsearch, Logstash, and Kibana. It kind of fits the same purpose as Splunk. You send all your logs to it. It provides a search engine for them, stores them, accumulates them from all different systems, and goes ahead and it really lets you do searches and lets you get do alerts and notifications based on it. So you want to go ahead and use some of those tools so that you can get an alert that, hey, this system is not behaving properly, or we're getting a lot of errors, or we used to see an instance of 1 out of every 10 got this error. Now we're seeing 9 out of every 10 is getting this error, or something like that. So you want to set up those alerts and get notifications to the people that can do something about it. Balance that. Don't just throw alerts just because you want to know every time someone places an order, or every time somebody does a search. Only set the alerts and send out notifications on things that you plan to take action on, because otherwise people just start ignoring them. They filter out all those messages. They don't pay any attention to them. You don't want to be the group that cried wolf. You want every alert to actually be something that someone pays attention to. Now, paying attention to doesn't mean they drop everything and this is an emergency. It might just mean that, hey, okay, I see that happened. We need to pay a little bit more attention to that for the next couple hours to make sure it goes back to where we normally expect it to be. But a lot of times it is, hey, we're seeing a high threshold of this. We need to have someone look into it and figure out what's going on and why this is just happening now. Look through your logs regularly, right? Review them. Look through your notifications regularly. Review those. Make sure that you're looking for repeated patterns, things that are happening over and over, even if it's something that's not necessarily an error that you would have hit on. Maybe it's something, hey, every time someone goes ahead and buys something, when they do their next search, they get this problem occurs, or they can't find what they're looking for because we didn't reset something, right? Log can actually tell you a lot about the state of your code, so it's worth looking through those logs manually every now and then, not just relying on those notifications. And it's also worth reviewing those notifications and make sure they're still valid. There's still things that you want to take action on, and you're not overloading people with messages that you don't care about. So that's elk stack. Um, Aside from just log monitoring, there's also system monitoring, right? A tool like Nagios can be set up to look at the status of systems, right? This is really not looking at an app in particular usually. It's more often looking at the system online or offline and how much CPU is being used, how much memory is being used. Are we seeing network traffic go in and out, right? A lot of times that'll tell it be an early way to say, hey, the system is down or the system's not working right, or we're having a hardware failure if you're in a data center. Um, the other thing is look for maintenance items, right? It can alert you to disk full conditions before you have a disk full conditions. It never ceases to amaze me how many organizations will put in tons of monitoring and security scanning and have whole groups looking at things. But you'll come in on a Monday and find that your system is down in production, that they didn't notice it, and it's all because a disk filled up. A log file got out of control and it just wrote too much to disk, and you know you have tons of people watching and tons of monitors running on it, and nobody thought to check for a disk being full, right? Those simple things that sometimes can really throw you off. The other thing is just being able to tell that systems are online. Like, a system got turned off accidentally and never came back up. It got patched and failed its reboot or something like that. Having something like Nagios that can just tell you, across the board, across your entire systems, across all your systems, across your entire data center, your cloud environment, can tell you which systems are up and running and which ones are not, which ones seem to be eerily quiet or should be seeing some traffic, which ones have CPUs pegged, which systems may need to get some additional memory added because we're starting to run near some thresholds, or like I said, just disk is full. They're getting to 80%, 90%. I mean, you never run. Typically in production, you run a system, at something like 50 to 70% capacity. You'd never let it get higher than that. So you could set alarms to say, hey, when it gets to 75%, for more than 5 minutes, 75% of CPU or 90% of memory or just 80% disk full. I want an alert so I can plan to take it offline and fix it. And then a lot of this gets down to continuous improvement. Now, I mentioned earlier on the Phoenix project and what they call the 3 ways. I talked about the second way. The third way in the Phoenix project is a culture of continuous learning. And that gets explained a lot as continuous improvement, right? We're getting all this feedback. We're getting tons of opportunities to make changes. So we want to take that feedback and act on it. And we want to constantly get things better. Now, we're never going to be perfect. So there's always going to be room for improvement. So we want to keep looking at that feedback and doing what we can to make things better. We want to try to be proactive, but we also are going to have to learn from our mistakes. We're never going to not make mistakes. So, when a mistake happens, you want to do something like, some groups have a formal after action report or review. Some places will have they'll do a root cause analysis. The goal of that isn't supposed to be blame. It's supposed to be, what could we have done better? What should we be doing in the future so that this doesn't hurt us as badly, or so that this doesn't happen again? And in the idea of continuous improvement, we're not waiting for major outages to learn from. We want to be constantly looking at how could we get better. Hey, running these scans and everything used to take a while. Now we're getting them a little bit faster. Or it used to take a while to figure out how to remediate them, and now we're going faster on that. So now we have some extra bandwidth. What could we do? What's the best thing we could do to improve our security posture right now? Our security testing right now, our security scanning right now, our hardening right now. What could we be looking at right now that would make the biggest impact for us, that we have time to do, right? Whether it's more tests, better tests, fewer false positives. A lot of people would look at something called the theory of constraints, which says you try to eliminate your biggest bottleneck and work to try to remove that. Because once that biggest bottleneck is gone, then your next biggest bottleneck becomes your biggest bottleneck. And the idea is that in the theory of constraints is that if you fix something other than the biggest bottleneck, it doesn't benefit you near as much, right? If you fix something that happens before that bottleneck, you just get to that bottleneck faster and you wait at the bottleneck for just as long. Or if it's after that bottleneck, you just have more free cycles after the bottleneck because that bottleneck's still your problem. So you always want to try to look at that in security as well. What's the best thing we can improve right now? Because whatever our biggest problem is, if we can fix that, That's our biggest problem. If we fix little things, maybe we get some little wins and maybe it helps us out a little bit, and maybe we're in that area of the code anyway, or that area of the pipeline, we can add a test. But the real big thing is if we want to address the big problems, because those are always going to be the big problems until we address them. So continuous improvement, always be looking to improve. All right, so let's wrap this up. Here are 5 key takeaways that I would say, my biggest things I would take away from this, things that I'd like you to learn or go back and try to implement. First, use threat modeling to understand your security situation. Like I said, formal would be great if you can do something like Stride, but if you don't have time to do that, don't have the experience to do that, just go ahead and start doing back of the napkin type. Let's talk this out. Let's talk about the day in the life of a user. Talk about how the data moves through the system. Talk about how the systems interact, and start identifying, here are some places where I think there could be risks. Here's kind of how people would be able to break into the system. And if you can do that, you have a better understanding of your security situation. You're better set up to make decisions and to add testing and to add scanning and to put effort into trying to fix those things. Next, avoid using components with known vulnerabilities, right? Like I said, this was the Equifax breach. Very easy to remediate, very easy to implement software composition analysis into your pipeline. So it's a low-hanging fruit. This is just a real easy one. It may not be the biggest bang for your buck. It may not be the one that stops, let's say, stops your company from going out of business because of a security breach, but it might be, right? Like with Equifax, or it might just be the one that it eliminates so many other problems down the road that it frees up a lot of time for you to deal with the next biggest roadblock. Automated deployments open the door for more testing and higher confidence, right? There are so many things I talked about that really based on the fact that we're actually doing a deploy of our system to someplace where we can do our testing, and we're using that same deploy down the road in all our other environments. So by the time we get to production, it's not, hey, let's cross our fingers and hope this deployment works. We know it's going to work because we've used it dozens of times beforehand, right? Plus, it gives you that ability to do the on-demand and the dynamic environments, right? There's a lot of advantages to it. It sets you up for success in so many places, well worth implementing. Remember that DevSecOps doesn't stop at release, right? It's not that once we get the software out the door, it's no longer our problem. We can wash our hands of it and move on, right? There's still monitoring to do. There's still logs to check. There's still software to maintain. And we're going to, not only doesn't DevSecOps stop there, but we keep getting feedback from the stuff that's in production. If you're developers, if you're business analysts, if whoever's writing the requirements and doing the planning for your product, if they're not talking to the people that run it, they're not talking to your customers or your production group that's operating this and finding out what's the biggest problems, and you're just losing out on tons of opportunities. And lastly, security is never perfect. Keep on improving, right? Continuous improvement, always be looking for the next big thing that you can fix. That's what you want to be addressing, and work that into a normal process that, hey, our pipeline's never going to be done. We're always going to be adding new tests and improving our tests and making our tests faster or more complete or fewer false positives, right? Always be looking for those opportunities. Use that feedback wisely. All right, if you have any questions, I'll be on the hub. I'm other DevOps Gene on the hub, and thank you very much for coming.